solar energy and latitudes. There is a difference in solar energy received at different places depending on the latitudes. You know that at lower latitudes, that is near equator, there Earth receives a lot of solar energy as sun rays fall directly there. And at mid latitudes, what is mean by mid latitudes? Latitudes which are near around 60 degrees, 60-degree latitudes. There we find the insolation is lower to the insolation received at tropics. And moving further, polar region, we find there very low insolation. That means there the inclination, the angle of incidence changes due to the curvature nature. So we find the energy, solar energy received at different places different, right? So there is connection between latitudes and insolation received at that place, right? Look at here. Here you see that the angle of incidence is different. What do you see here? Sun rays are falling straight. 90 degrees angle is there. What you call between the sun and the earth, right? And further, what do we see here? You see here, let me show you insolation at mid latitudes. What I am saying, insolation at mid latitudes here. Okay, how the sun rays are falling here due to the curvature nature. Here it is a slant, right? That means the angle of incidence decreasing there. So the latitudes here, it is a 0-degree equator, and here around some 50-degree longitudes, 50-degree latitudes to some 70-degree latitudes. And further here we find it is 90 degrees north, 90 degrees north. So there the insolation received is low. So what is happening here? As the latitudes are changing, insolation received also changes. At lower latitudes, what do we see? High insolation received there. And at higher latitudes, that is at North Pole and South Pole, the insolation received is very less, so that those are very cold, right? Look at here. Our earth is rotating and revolving around the sun. So as it rotates and revolves, it bends slightly. That means 23 and of degrees it bends. How much? 23 and of degrees. So some of the at some places on the earth here, the insolation received is high because of a angle of incidence that is 90 degrees. And here the sun rays fall slantly, right? So that their insolation is low. And moving at North Pole here, uh, look at that, the sun rays are going in this way falling. It may not touch also sometimes, right? It is going into space without touching it because Earth is in a spherical shape and it is tilted. It is bended some 23 and of degrees. So at low latitudes, insolation is high, and at higher latitudes, insolation is less. It means that where insolation is high, there the temperature is high. Where insolation is low, there the temperature is low. So what do you understand here? At 90 degrees north and south pole, there the insolation received is 40 units. At 66 end of degrees, either Arctic Circle or Antarctic Circle, there 50 units of insolation is received. And at 45 degrees, that is at Japan, it is 75 units of insolation is received. So where insolation is high, it is at Japan. So that there the temperature is high than the polar circles, that is Arctic Circle and Antarctic Circle, and North Pole and South Pole. Understand? So insolation received on Earth depends on the latitudes, right? More intense sun rays fall on a equatorial region, where at equator. And we know that usually every day at midday time, there the cloudy forms and less sun rays fall on the ground. So equatorial regions are not very hot when compared to the tropical regions. What is meant by tropical regions? The region which is either sides of the equator, which either sides of the equator. Let me show you what is meant by tropical zone. Okay, look at here. This is our Earth. What I am drawing. You know that the middle circle is equator. Okay, and another one I am showing with yellow color. This is the region, tropical region. Okay, you know the pressure belts which are shown, right? So this is a tropical region. Which region? Tropical. So in the northern hemisphere and in southern hemisphere, we find a tropical zone to the near to the equator. That means either sides of the equator. Okay, very adjacent to the equator, we find a tropical zones. Okay, at equator, sun rays fall directly over the head, but due to the cloudy in the midday time, there the sun rays fall very less. Okay, comparing with the tropics. Okay, we are comparing the temperature received at equator, temperature received at equator with tropical region. So where do we find a high temperature? It is at a tropical zone. Okay. And then after we find somewhat less temperature at equator. Further, less temperature is received at polar circles, that is 66 and of Arctic and Antarctic circle. And it is very, very less, that is very cold. Temperatures are very low at North Pole and South Pole, right? So here, what is the relation here? As moving from low latitudes to higher latitudes, the insolation received is decreasing. It means that the temperature decreases. So there is a factor influencing the temperature on the Earth's surface. What is that factor? It is latitudes. Okay. So latitudes are important to know the insolation and the temperature recorded at different places. Okay. So equatorial regions are not very hot when compared to the tropical zone, which are very adjacent to the equator. So if you look at this table, you will understand. Okay, right? Japan is located at 45 degrees north, what to call latitude, and there the insolation is 75 units, so that the temperature is high. Okay, and at 90 degrees pole, insolation received is 40 units, so that there the temperature is very less. So at a higher latitudes, this is 90 degrees is a higher latitude, there the temperature is very less, that is low. And at lower latitudes, that is 45 degrees latitude is lower latitude comparing with the 90 degrees latitude. So there the insolation received is 75 units. So the temperature recorded at that place is high. So there is a relationship between temperature and the latitudes. So latitude is one of the factor influencing the water temperature. Okay, moving from low latitudes to higher latitudes, the temperature decreases. Okay, right? And another factor we see here, the relationship between temperature and land water relationship. We know that our earth is covered with land part and water part, that is continents and oceans, right? So here land is a good conductor. What do you mean by good conductor? uh, it absorbs the water heat. What do you mean by heat? One insolation is received, then there the heat is generated. So on the earth's surface, due to the insolation received, it becomes heat, and heat we measure in temperature. Okay, so that what here, land is a good conductor of heat, whereas water bodies are different. Land gets heat very fast and also becomes cool very fast comparing to the oceans. Oceans takes a long time to become heat and also becomes cool, taking a long time. So there is difference in the absorption and what to call releasing the heat by land and water bodies. So when insolation received at a land part, what that? At a land part and water part. Where do we find high insolation received? That is at a land, because it absorbs very fast. So here the temperature will be high, okay, because it absorbs very fast. Understand? Water body absorbs heat very slowly, so that here temperature recorded is low. Okay, that means we find a less temperature on the oceans, rivers, seas, and high temperature at land part, that is at continents. So due to this difference in the temperature of land and water body, we find there land breezes and sea breezes. What do you mean by land breeze and sea breeze? Look at here. A breeze blowing towards the sea from the land is called land breeze. What do you see here? You see there a wind blowing from the what to call land from the land part to the sea is called land breeze, and a wind blowing from a sea to land part is called sea breezes. So during the night time, there we see sea breezes are formed because land becomes cool very fast comparing with the water body. So at night we find it is warm on oceans than the land part. So warm breezes starts coming from the sea and increases the temperature at land part. In the daytime, it becomes reverse. Daytime insolation is received by the land part and water part. Land absorbs very fast and becomes heat very fast. So that in the daytime, what do we see? High temperature is received at land part here, high temperature. And the low temperature is recorded on oceans, on oceans, understand? So that what here, due to the temperature difference, the wind blow from the land part to water body, that is to ocean, and that is called land breezes. Okay, so the hot air from the land moves towards oceans. Okay, that is warm air from the land blows towards oceans. Warm air blows towards the ocean. Look at the slide. Here the warm air blowing towards the ocean. Oceans are somewhat less in warm to the land part, so that cool air from the ocean blows towards land. So by this process, there the temperature maintained more or less equal at the places which are near to the oceans and to the seas. So what I want to say here, the place which is near to the ocean or to the seas or to the rivers record less temperature than the places which are far from the oceans. Understand? That is the reason we find at Chennai the temperature is less when compared to the temperature recorded at Delhi, because Chennai is near to the sea, right? And whereas Delhi is far from the water body, understand? So there is a difference in the temperature recorded at land part and the water part. Okay. So why do we have such a difference in the temperature recorded at land part and water part? Because there is a difference in the absorption of heat by land and water body. Land absorbs very fast and becomes very fast cool. Water bodies absorbs heat very slowly, so that it becomes slow heat very slowly, and also becomes cool very slowly. So that what will happen here, the places near to the sea will record a less temperature than the places which are from the ocean. Okay, right, let me show you that here how it is instead. Here you look at I'm drawing our India instead. This one, wait, I'm drawing. Look at, my dear students, southern India I'm drawing. Okay, this is our India. We are moving in this way. So where do we find Chennai? Here is Chennai, which is in Tamil Nadu, right? What it is? It is Bay of Bengal. Where is Chennai? Near to Bay of Bengal. It is a ocean, sorry, sea, right? So that we know that the land absorbs heat very soon and becomes hot, and the water body absorbs very slowly. So that what happens here, the temperature recorded on the land part should be high, but it will be decreased by wind, cool air blowing from Bay of Bengal. Okay, cool air, this is the cool air blowing towards land part, so that the temperature at Chennai recorded less. Okay, so here the Chennai is near to the water body, that is the Bay of Bengal, so it records a very less temperature compared to the Delhi. Where is Delhi? Let me show you. Here I'm drawing the north part of India, understand? This is right. Here we find Delhi, understand? What that? Delhi. Okay, so Delhi is far from the water body, so here it records high temperature. Which one? High temperature, because it is far from the ocean, or not. So in this way, there is a difference in the absorption of the heat by land and water body, so that the temperature recorded at the places near to the water body is less than the places which are far from the water body. In the example what I given, Chennai and Delhi instead. So up to now what we discussed here, the factors influencing the water temperature. What are those factors influencing the temperature? One is latitude, and another one is land water relationship. Okay, yeah.